Okay, I think this is for Aubrey. We're on 2-1. We're starting to actually do some stuff with data. This right here in front of you at the top of the page is something called a frequency table or a frequency distribution. Okay, there are two things involved in a frequency distribution. The first one on the left column is always your classes. Okay, in this case, these are ages that the Academy Award was won for a Best Actress. So they're talking about Oscars or Academy Awards, what age those females were when the Academy Awards were won, right? Like how old were they? This person won when they were 35. This person won when they were 27, whatever, right? Okay, and then this guy is the frequency, as it is labeled. He is called the frequency. Frequency means what? How many there are in that class, right? So there were 29 people that were aged 0 to 29 that got that Academy Award, right? There was only one person to ever win the Academy Awards or the Oscars in their 80s to 89-year-old age. I have no idea. Somebody like real good, like Betty White or something. I have no idea.
Why did your mind go to Betty White?
I don't know.
You're an old head.
Oh, come on. But she's old. Like, she's old. I'm trying to think of anybody that's that old and whatever. Okay.
She was old.
Now,
She died.
yeah.
I know, but you can't just...
Yeah. Anyway, all right. So you have classes, you have frequency. Got it? Questions about this? Now, we can, from this table, draw some conclusions. Like, one of the things that I see from this table is that the majority is younger. Okay? And eventually, we will start to compare females versus males using a frequency table. And it just so happens that, I'm sorry, females, this is the way that it works. We get wrinkles faster. We age not great. And men age like fine wine. Evidently, they're just ugly to begin with, so it doesn't matter, right? But they age like better than females do because they don't have actual stress in their life, right?
Yes.
But don't we
So-
stop, like, puberty sooner than they do?
Yes,
Like,
right. We mature faster than they do, and we whatever, all the things, right? Okay, so if we have these frequency tables set up back to back, we can see that, like, the females are younger when they are successful as actresses.
The males are for sure.
Okay? Males, you're going to see more of like this region probably happen, right? They're still like messing around in this age, right? Then they start to finally like buckle down and get careers, and they're actors in this region. And they are allowed to do that because they look the same age when they're 55 as they did when they're 35. That's just the way that it goes, men. Sorry. So they might have a little bit different of a trend there, okay? So with this frequency table, we can start to compare and do some things. Got it? All right, let's learn some vocabulary. Here we go. Vocabulary. We have classes, we have frequency. Our lower class limits. Lower class limits, according to this, are 20 and 30 and 40 and 50 and 60 and 70 and 80. Those are the lower edge. I'm going to say the lower number of each class. Is that self-explanatory? The upper class limit, where it limits it, is the higher number of each class. Okay? So I'm going to go 29, 39. I'm going to go ... because I'm lazy, and I'm going to go 89. Got it? If you list them all out, that's totally fine. But I'm just going to be lazy.
50 on
Okay.
groups.
All right. Class boundary is the hardest one for me to explain. I'm going to skip that one. I'm going to do that one last. So we're going to go down to class midpoint, the middle of each class. If I'm looking at 20 to 29, 20 to 29, if you're looking for a midpoint, finding the midpoint is like finding the average in geometry class, right? Okay. So if I'm averaging them, I would take 20 plus 29 and divide by 2, and that is 24.5. Okay? It is the middle of each class. Okay, so I go 20 to 29. That middle is 24.5. The next one would be 34.5. ... The last one would be 84.5. Okay? Questions about that? All right, these next two, those three were pretty easy to figure out. You could probably figure out those without me having to teach them to you. These next two, you have to listen to. Are you ready? These next two are important because people screw these up a lot. Okay, let's go class width. All right, how wide is each class?
9.
No.
10.
11.
A lot of people say 9 because they say how wide it is from 20 to 29. But the class width is measured from 20 to 30 to 40 to 50. There's 10 between those, or you could go from 29 to 39 to 49 to 59. The class width is 10. Okay? All right? I'm glad you said that though, because now you won't ever, you learn from it. You'll never make that mistake again, right? Not really a mistake, but anyway. So the class width is 10. And that's just one number, right? Each class width is 10. You want them to be 10 units wide. So I'm going to say from lower to lower or upper to upper. Do you know what I'm talking about that?
Yep.
Okay. So it is not 9, it is 10. Got it? But a lot of people say 10. Eli's going to get to the test and he's going to still say 9. Because he's not going to listen. Okay? All right, last one is class boundary. Okay? And this is a little bit hard for people to understand. Okay? Especially with this right here. Age is pretty well, like, you can kind of figure this out, I guess. But imagine that this was like temperature, okay? Imagine we were dealing with temperature from 20 to 29, 30 to 39. These are degrees, right? What happens if I have something that is 29.5 degrees? Where do I put that?
29.
30 to 39.
That would go here?
Yeah.
Yeah, I agree. What about 29.1?
Stay. The 29.
That would go here. So what's the cutoff mark?
49.
0.5, right? Your cutoff marks would be 29.5 for the 29.5 for the first class. 39.5, 49.5. The last one would be like what, 79.5? I'll go do ... Yep. Boundaries. So it is the, how do I explain that? Yeah, that sounds good. The point where we round up. Okay, let me do a harder one for you. Say round up. Nope, I'm not gonna do any negatives. There's not gonna be any negatives. There's not gonna be any negatives. Okay.
I'll take math over temp.
All right, we ready? Let's say we are doing temp and my classes are going from 20.0 to 29.9, 30.0 to 39.9, 40.0 to 49.9, right? What's my boundary here now?
29.95.
Yeah, 29.95. It would be like the additional 0.5 off of that, right? One more extra decimal place.
Hold on.
This would be 39. Do you see how that works? If there's an additional decimal place, it would be the 0.5 after that would tell you how to round. Does that make sense? Mm-hmm. Okay, so that's a little bit weird. Those are your boundaries. It tells you how you're going to round up and down. Because typically your temperature or your classes are typically in like whole numbers or to one decimal place or whatever. But what if you have something that's 2 decimal places, right? How do you round? There you go. Questions about that? All right, let's go on down. Okay, when we're conducting a frequency distribution or we're making one. What? Hold on. Yes.
Doesn't make any sense for years because, like,
I get it with age. Like, technically, if you're 29.6 years old, you're still 29, but they would put you in the 30 to 39 category, according to class boundaries, which is weird.
Interesting.
Yeah,
but not actually.
So
I
would
know,
be
but not actually, right? So you have to be careful, like, you know.
So I'm 18 category then, even though
So you're at 18. You're 18. Yeah.
At this
So-
rate, I'm 21.
But if the
Anyway.
boundary is
Yeah, and then like they don't like.
Yeah.
Say you're 18. And
Yeah.
then after
So
you can just be
that's how they do it that way. Whatever. But typically, sir, typically, you're not going to have your data come in as 17.6 years old. It's just going to say 17, so we'll still lump you in the 17 category. This is only if your data has additional decimal places beyond what the table classes have. That makes sense?
If the boundary is 11 and it's 1, 11.
Okay? Okay, now, we're going to be constructing a frequency distribution. Here's how we do it. Ready? The first thing, we have to figure out how many classes we want, the number of classes, and typically it's between 5 and 20 classes. Okay? 5 and 20 classes. If you have not very many data points, 5 classes is fine. If you have like tens of thousands, I would do 20 classes and maybe narrow them down a little bit smaller, right? Okay? So it just kind of depends. 5 classes is minimum though. 20 classes, if you get more than that, it gets to be too crazy. Okay? So 5 and 20 classes. I usually say 7 is good. 7's a good number. Okay? All right, now, how do I decide what my class width is? Okay, so here's your class width. We're taking the highest data value. We say, like, how high do we need to go? Right? So maybe if we're talking about scores on a test, the highest score on the test was a 100, right? The minimum score on the test, we're not going to go 100 to 0 because the lowest score was a 60, right? We're going to go from 100 to 60, and I want to do, let's say, 5 classes. Okay? So 100 to 60 is 40, and 40 divided by 5 is 8. Now, here's a huge problem. Okay? Here's a huge problem. That came out nicely as 8 for my class width, right? That would mean like I would start at 60 and I would go, I would go from 60 to what?
68, 67.
67, 68 would be here. 2. Okay, I'll keep adding. This would be 76. So this one's 75. This one, if I add 8, would be 84. If I add 8, would be 92. If I add 8, would be 100, right?
It's just not pretty.
Okay, you see how this works? Ready? This guy would be 83. No.
Yeah?
Yeah, 83. This guy would be 91. This guy would be 99. Okay, the problem is, do you see how this works? We said we wanted 5 classes and we started at 60, which said our class width should be 8. But the problem is, and I think this is here, minimum class, convenient, blah, 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 below the minimum. Nope, it doesn't say that. So when you divide for your class limits, if you come out with a whole number, you must round up to the next one. You always round up. So if it came out as my class width needs to be 8, we actually have to do 9. Does that make sense? Because I want to include 60 and I want to include 100. Okay? And if I don't, you can see here, if I start at 60 and do a class width of 8 and I do 5 classes, I'm not going to hit 100, right? So I would have to do a class width of 9. What happens if that came out to be 7.1? I would round up to 8. My class width would be 8, okay? So you're always rounding up even if it comes out as a whole number. Got it? Otherwise, you're going to not catch that top number.
So but what if, like, if it comes out as
Then you always
then,
round
like,
up to the next one.
Your top, like, your highest category would be, like, less than that, right? Like, say you had 7.1, but you went to 8.
Mhm.
The last one would, like, go to, like, 6.
Right. So your classes would end up being like the cutoff for your classes would be at different spots. So, and if you decide to do 7 classes and you decide to do 5 classes, your tables are going to end up funky weird anyway, right? So the cutoffs are going to be weird. All right. Okay, so let's do this example. Let's do, one more thing. Instead of doing this right here and starting at 60 exactly, we could start at a convenient number, right? So it says, number 3, choose the value for the first lower class limit by using either the minimum or a convenient value below the minimum, okay? So if my minimum number was, let's say, 63, and my highest number was 100, and I wanted 4 classes, I could just go 60 to 69. I could go 70 to 79. Does that make sense? I guess I couldn't do that. I would have to go like 59 to whatever. just so I caught 100. Anyway, but I could choose a convenient number below 63 in order to start, and I could just do everything in the 60s, everything in the 70s, everything in the 80s, right? Whatever. Okay? All right, let's go here. So we're constructing a frequency table using McDonald's lunch service times. So follow the above procedure to construct a frequency distribution. This means, what does 107 mean?
Seconds.
Seconds. That's how long it takes for me to order my food to the time I get my food. 107 seconds is a little like over a minute and a half, right?
That's not accurate.
That's not accurate. You think you wait way longer than that.
More than 308.
Okay, what's my max time? What's the longest somebody waited?
308.
Wait, no. There's
308?
Oh, wait.
Is 308 the biggest?
Yeah.
He is right here. 308's the biggest? What else? Min? What's the minimum number? 83? I saw a 90 and a 91, but 83 I think is lower. How many numbers do we have?
1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16,
times
47.
3 is what?
17 times 3. Is that. I got set.
I got 17.
2, 4, 6, 8, 10, 12, 14, 16, 17 times 3
51.
is 51. So 50, because there's no 1 there. Okay, so there's 50 numbers. We don't need to know the 50 numbers, though. How many classes do we have?
Probably
Look at the table.
1, 2, 3, 4.
5. They wanted 5, right? They set this table up for us, right? They wanted 5 classes. Did they tell us up above that they want? Oh, yep, use 5 classes. All right, here we go. So, what's the strategy? Let's go. I'm just going to do 308. I'm going to use the whole number. 308 minus 83 over 5. I want 5 classes, right? I want 5 classes. 308 minus 83 is 225. Is that true? I have no idea. Yeah, 225 divided by 5 is 45.
Well, you can do like 46. You have to round up.
We could. Yes. So since it came out as 45 exactly, I would have to do 46. Okay? I'm going to change things a little bit on us. Okay? Instead of going 45s, I'm going to go 50. Instead of 46, I'm going to go 50. Okay? But I'm going to start not at 83. I'm going to start at 75.
Oh,
Yeah?
yeah.
Would that be a nice number to start at?
Yeah.
Okay?
So 75 to 125.
75. The next number would go to 125. So it would go 75 to 124.
4.
Okay? My next number up from 125 would be 175.
Can we go down?
You like going the other way?
No, I don't care.
Oh, yeah, we should go this way. You're right. 75 to 124. It doesn't matter. It doesn't matter. 125 to, this would be 175, so that would have to be 174. Okay? Next number up would be 225.
Hold on.
Next number up would be 275. And we're going 224, 274. This number, next number up would be 325, so this has to be 324. You see my method of my madness here?
I don't like your madness.
I'm sorry.
I'm scared.
Okay, now, will we catch the bottom number?
Yes.
Yes, will we catch the top number? 308 was our top number? There you go. And those are nicely drawn out like classes, right? Okay? Got it?
So then we do like the homework and stuff.
I will tell you what to start on, and I'll tell you how many classes. Yeah, just so everybody's the same. Because you might have done it. You might have started at 83. Like I would have started at 83, and I would have been like, I'm going to do it exactly the way I was supposed to. Start at 83. I'm going 46. Like, that's what I would do. Because that's going to be, like, the most accurate. And they're like, nah, you'll get a general rough idea of the distribution. Because that's what we're going to be looking at later on. Distribution, if you do it nice, easy increments. They're just trying to make it so it's easier to put these numbers into the frequency table. Whatever. So. But yes, I'm like you. I would have liked to do like exactly the way it was supposed to. But they will tell you, I want a class width of this, and you're going to start at this number. Yes. So, just so everybody's on the same page. Okay, so, yuck.
We don't want to count. We're going to guess.
All right, I'm going to tally. So, first one. Okay, you just watch. I'll tally them, and you make sure I put them in the right spot. Okay? So 107 goes here. 139 goes here. 197 goes here. 209. Would that be easier? Yeah, sure. 281.
254.
254.
163.
163.
150.
150.
127.
127.
308.
308.
206.
206.
187.
187.
169.
169.
83.
83.
127.
127.
133.
133.
140.
140.
143.
143.
130.
130.
144.
144.
91.
91.
113.
113.
153.
153.
Yep. 255.
255. Shh.
252.
252.
200.
200.
117.
117.
167.
167.
148.
148.
184.
184.
123.
123.
153.
153.
155.
155.
154.
154.
100.
100.
117.
117.
101.
101.
138.
138.
186.
186.
196.
196.
146.
146.
90.
90.
144.
144.
119.
119.
135.
135.
151.
We're close.
Yeah.
Okay. 151.
197.
197.
171.
171.
190.
190.
And 196. Or 169.
And 169. Eh?
That's a lot.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Put 11 under the first grouping thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 1, 2, 3, 4. Shh.
You messed up.
6, 7, 8, 9, 10. 10?
I watched you mark 146 and the 225 to 270.
We don't care. 4 and 2. 11, 23, 10, 4, 2. 11, shoot. 11, 24, 10, 3, 2. 24. 10, 3, 2.
Oh,
Wait.
who was right?
I screwed it up.
Yeah, Elon.
And you didn't say Mrs. Comacher! You
I
marked
did.
it wrong.
I did.
You did not either.
Yes, I did.
I didn't hear you.
I just said it and you told me to shut up.
I'm talking about at the time.
She's so mean.
I'm talking about at the time. All right, so 11, 24, 10, 3, 2 is what it should actually be. You see, it's kind of hard.
Where'd you find those answers?
On the next page.
I told you your mistake.
What? Oh my gosh. I could have just told you those and I didn't
Right,
have
right.
to do it.
But we have to go through the process, right? 11, 24, 10, 3, 2. All right, so some general conclusions that you can draw from this frequency table.
There.
Most of the time, it is going to
125 to 174.
take 125 to 174 seconds, which is 2 to 3 minutes, yeah?
Yeah.
2 minutes is 120, 3 minutes is 180, right?
You should take
So
that
2
one
to 3 minutes is how long it takes
to order.
most of the time. Most of the time. Got it? There you go. Okay, what time do we get out here?
In 2 minutes.
Okay, one more thing. Next page, example 2. Top. The top of the next page, categorical data. All right, we can do a frequency table where your classes are categories, right? These are categories. The other ones were like ages and times, which are quantitative data, right? Quantities. These are categorical data. So bicycling, football, playground, basketball, whatever. If you have categories, you typically put them in order from, you could do alphabetically. These are greatest frequency to least frequency, right? So let's read this because I was surprised by these results. So this table is listing the highest 7 sources of injuries resulting in visits to the ER. The activity named are categorical data and the nominal level of measurement, and we can create a frequency distribution as shown. It might be surprising to see that bicycling is at the top of the list, but this doesn't mean that bicycling is the most dangerous of these activities. Check this out. Look at this. Bicycling. People go to the emergency room from bicycle injuries more than ATV accidents. Why is bicycling more often than ATV accidents?
you die.
I think ATV accidents are going to be more
Deadly.
dangerous than bicycling.
They're more deadly.
All the whole.
Everybody's bicycling, right? Like everybody has a bike. This is considered like old people riding a bike, young people riding a bike. There's everybody riding a bike. Not everybody has an ATV and is out there every day, right? Okay, so there's more. This is more frequent, and there's more people doing it, right? What? What'd you say?
I was just gonna add.
What?
People don't wear helmets.
True.
Do you buy?
I don't know.
No.
Okay.
Don't hit on the breastplate.
Yeah. Like I think ATVs are more like dangerous than being on a playground. But there's more children on a playground every day than there are people in ATVs every day, right? Okay. So that doesn't necessarily mean that there's more like whatever, like it's a higher frequency. Got it? Good?
What do we got?
I don't know. What time do we get out of here? Okay, we'll stop. We'll stop. A couple minutes early, we'll stop. We've got like 8 minutes left. Okay? There we go.
What is 7
Goodbye.
plus 22 plus 14 plus 2 plus